with our investigation of quadratic functions in vertex form. In tomorrow's class, we're going to look at what are called translations of quadratic functions. But for tonight, I thought I'd give you a break and give you a recap of what we learned about vertical stretches and reflections of the function f at x is ax squared. So the value of a determines if the graph has a vertical stretch. So if I'm expanding, so my arms are going up to the sky, or it's a compression where my arms flatten like a pancake if I use my arms to represent the U-shaped curve f at x is x squared. Now, I could also have a reflection in the x-axis based on the a value. And that occurs when the a value is less than 0 or negative. When this occurs, the function is reflected in the x-axis. Critical points, on the other hand, are your maximums and minimums. When the coefficient of the coefficient of x squared is less than 0, that means the a value is negative. The function opens down and it will have a maximum. When the coefficient of x squared is more than 0, that is a is greater than 0, the function opens up and has a minimum. Vertical stretches occur when the a value, the vertical stretch factor, is greater than 1 or it's less than -1. So we need to put a negative sign in there. The function has a vertical expansion by a factor of a. Similarly, if a is between -1 and 1, the function has a vertical compression by a factor of a. And today we also noticed that some points didn't change at all when we stretched and reflected them. And the point that didn't today was the point 0, 0, and it's what's called an invariant point. Invariant points always occur when the point does not change when you have a transformation. If I asked you to graph this, looking at this quadratic function, we don't want to graph it, we already have the graph. The question asks us, given the quadratic function, so we've already got it, we need to find its equation, its domain and range, and the intervals of increase and decrease. So right off the bat, the first thing we want to do is find its equation. Well, I know so far the only equation I've worked with is f at x is ax squared. Now I know that the vertex is at 0, 0, and I haven't shifted left and right, up and down. So I'm going to start with f at x is x squared. I need to pick a point on the graph because obviously I've got to figure out what a is. And the point I'm going to pick, I'm going to go to a nice point, and this one here looks pretty nice, 2 and -1. Okay. I could also have picked, where's another nice point? Doesn't look like there's anything else very nice here. Oh, I could have picked -2 and -1 right here because that's also a nice point on the graph. I don't want to pick the vertex though because the vertex I've already accommodated for by choosing f at x is ax squared. So I need to pick a different point on the graph. So I'm going to substitute -1 in for f at x, and I'm going to substitute 2 in for x. And notice how I put my brackets there first, and now I put my 2 in to make sure that I solve my equation appropriately. And now I can do my exponents. So it's -1 is 4, and I divide both sides through by 4 to solve for a, and I get a is -1/4. So my equation is actually f at x equals -1/4, and that makes sense because it's opening down and it got flatter, so the equation makes sense for what I'm doing. The domain, of course, it's a quadratic. If I think about the equation, I can take any number I want and square it and multiply it by -1/4. So the domain is just x belongs to the set such that x is an element of the real numbers. And the range, well, y doesn't go above 0. If I look at my graph, there's no y values up here. They're all less than or equal to 0. So I have to put that in there, less than or equal to 0. And it touches everything, so it's an element of the real numbers. Finally, it asked me to find my, that should not say C. It asked me to find my intervals of increase and decrease. So if I look for my increase first, I want to change color pens here. If I look here, over here to the left of 0, I'm actually increasing, aren't I? So my interval of increase is x is less than 0 and an element of the real numbers. I'm just going to put an I here to indicate that that's my interval of increase. And therefore, my interval of decrease is the part to the right of 0. And you can see that the y values are getting smaller. So I have to write x is greater than 0 and an element of the real numbers. And I'm going to put a d there just so you remember that it's the interval of decrease. And that's it. That'll help you do the questions that you were assigned for homework today in class, and we'll see you tomorrow.